Hello and welcome to the Just Heat Pumps podcast. I'm Xerxes.
And I'm Aaron.
Today we're going to be talking about the building science that goes along with hand-in-hand heat pump design. And today we have expert building energy audit certified BPI auditor, Aaron Shine.
You're very kind. Thank you. I would call myself more of an amateur building scientist learning every day. But yeah, today we'll jump into it. Energy efficiency is so key to proper heat pump design, and oftentimes it can make or break whether it can even work in your home on an extreme case, including the ductwork and other things. But we're going to talk about building science, building envelopes, and major components of that. So what encompasses a building envelope? Which a building envelope, firstly, you can define it as the building shell. And you can picture what in your home is conditioned by your current air conditioning or furnace or heating and cooled. Those spaces that are considered inside the building envelope. And then the outside is outside, obviously, the building envelope, but we want to condition and tighten up what's inside. So in general, in energy auditing and energy efficiency in general these days, you want to create a tight building envelope that keeps the conditioned air inside the home. And in the winter, what happens is general science is hot moves to cold, high pressure moves to low pressure, right? And
thermodynamics.
Thermodynamics, that's right. Talking to the physicists here. And in the winter, you have exfiltration, technically. It's when the hot air that you're producing inside the home moves to the exterior or leaks outside. And then in the summer, our homes can be pretty hot because the hot air outside is trying to leak in. It's trying to force itself in the home. And those are the directions in different seasons that the air is leaking. So if we can slow that down in a healthy way, there is a point where you can have a fully airtight space and be very unhealthy and have no breathing room or healthy air movement. We want to find a good balance with all of that. So what are the major components of this as it relates to heat pumps? One is air sealing, slowing down the air leakage rate. And
it's like money flying out the window.
It is like money flying out the window. You're paying to condition the air, and then it just escapes. And that's a lot of our utility bill. Often the utility bill is 40 to 60% or more of the entire energy bill to keep us comfortable in our homes. Air sealing is also usually the best return on investment you can do for the money spent, or the quickest payback. Is another way to describe that.
Well, also, when we model the heat needs for homes in our manual J calculations, in our heat load calculations, when we simulate how much heat you need when it's really cold outside, it's called variable sensitivity. Which variables are the most sensitive to these heat loads? And air sealing is by far and away the most sensitive parameter. So fixing air sealing is, like you said, the highest return on investment. And oftentimes it's a tube of caulk, right? It can be a spray can of foam, $20, $30 in, an afternoon, and you've just locked in, $100 in savings for the year. So
a quick trip to Home Depot or Lowe's, and like you said, caulk or spray can foam. And I've renovated a couple net zero homes in the past myself where I did this air sealing in an afternoon, and this was back in Florida, but all of a sudden in the summer when it's 98 degrees out, my air conditioner the home could not get below about 79 degrees in the home.
Oh, wow.
And then I went around with caulk and spray foam, and we did the blower door test before and after and took the air leakage down by about half. And usually in many homes here in Denver and Colorado, there are similar cases where you can find a few low-hanging fruit areas to really seal up the home, or the attic space or the attic hatch. We'll get into that in a little bit. But in my case, I was able to finally get the home down to a comfortable 70 degrees because the air wasn't leaking out. And again, in summer, you're preventing more of the hot air from outside coming into the home, so the air conditioner can work less and actually fill up the home with air-conditioned air. Here in Denver, it's more of a heating climate where we're trying to keep the heat in more so than in the summer, keeping the home cool. And air leakage, or I should say air sealing, will solve the same problems. And then we move on to insulation. And insulation typically comprises of insulation in the attic, insulation in the walls, and also in your basement and or crawl space area. And so it's usually air sealing and insulation go hand in hand. We start with air sealing, seal up the building envelope, and then move on to low levels of insulation. And you usually go for the attic first, next might be the crawl space, and then you can maybe tackle the walls, which is a more usually a more expensive project. And from a heat pump design perspective, when we're running the sizing calculations and heat load calculations, generally we can see a very big change in the building model when we combine air sealing, better air sealing, and in particular attic insulation.
We've seen building design heat load calculations come down 40-50%
Yes.
in many cases, and you're talking about maybe having a giant, the largest heat pump ducted system you can get, plus a huge electric backup system, or just even saying, oh, I can't even do it, I need a big furnace and maybe a little heat pump on top. And after air sealing and insulation, bringing it to a level that's actually pretty modest, hey, you can actually run this very efficiently. And that's the whole point of it, right?
Yes.
Is to bring the envelope of the building, the efficiency of the home to a level that gets you equipment that is just in the sweet spot. Yeah.
There's so many benefits. One would be just general comfort. Again, your mechanical systems are not turning on and off all the time. It just generally, it feels better in the home.
Home comfort is actually critical.
Yeah.
I mean, with home comfort, you're talking about hot spots and cold spots. So you have a heat pump that's right sized and the building envelope's good. Then your cold zones start to become in equilibrium and more balanced with the rest of the home. That thermostat is actually reading most of the house at that point, not ignoring the bedroom that's upstairs in the corner as much. And I think that's really awesome. And it kind of brings up another point for not oversizing the heat pump, because when you oversize a heat pump, it'll short cycle,
Right.
and it'll just satisfy the thermostat and leave those more further points of the house to just either be cold or hot.
Yeah, and we're at the point now, as a heat pump company, we're looking at energy audits almost every day. Whether we do the audit ourselves in-house, we are signed up with the Excel audit programs and the whole home efficiency programs, and I'll touch on rebates in a minute, but we often review energy audits from homeowners that any energy audit can do, and we can plug those numbers right into our heat pump design. Not only that, I would say over half the homeowners we work with now either have an energy audit or we talk to them or talk to you and advise to go get one, because the data that we find by doing the blower door tests, by knowing the actual insulation levels, not only allow us to size the heat pump correctly for what you have right now in your home, but we can very accurately forecast what your future home looks like with the upgrades.
That's right.
And not just home comfort. Your energy bills will be low, but let's talk about rebates for a second here in the Denver metro area. With Excel Energy, there are lots of rebates right now for energy efficiency as part of the whole electrification movement, the sustainability movement, air quality around town here. There's a lot of motivations for full electrifications of homes, and there are tax credits and rebates throughout the state. I'll just stay on Excel Energy for this one because they're the biggest utility in the state. But one, you get standard rebates for air sealing and insulation separately, depending on what your home might need. And then, of course, the really big heat pump rebates. Be sure to check out our other video on heat pump rebates and incentives around the state. But when you combine many of these projects, there are also bonus rebates, specifically the whole home efficiency program from Excel Energy. Basically, if you do 3 projects in a 2-year time frame, you get about 25% bonus rebates. There are different levels of rebates, but we often work with homeowners to figure out exactly what the best plan forward is for comfort and maximizing the rebates and lowering the equipment size of the heat pump so that we can fit it in your home and it works super efficiently down in negative temperatures without a whole lot of backup heat, and you get the comfort and lower bills along with it. It's just a total win-win across the board when we're able to combine the energy audit, the rebates, and everything else.
Well, and connecting that with the design, when we're doing the manual J's and we say, all right, your home's leaky. It's in the very leaky category. I mean, that's kind of the one where we always are, okay, we don't know that we can do a heat pump in your house if it's this leaky. You're going to be cold. It's not going to solve any problems for you. It's going to cause more problems. And that's one thing we definitely pride ourselves is avoiding installing problems in people's homes.
Yes.
And so we can model the home, bring down air leakage rates 50%, bump up insulation levels in the attic, say 50%, and then predict the performance doing this A-B comparison, this before and after snapshot of what life is like if you don't do the energy efficiency upgrades for your home. And you get, whatever heating system, it's probably going to feel very similar versus doing the energy efficiency upgrades, getting a more modest, more kind of balanced and optimally designed HVAC system. You're often saving 50% on your heating bills for the year. And that performance prediction is a really powerful tool. And it motivates kind of this journey along the whole home efficiency program, which actually is kind of a commitment. All those rebate forms.
Sure. A lot of rebate forms, a lot of paperwork, a lot of planning. However, it's completely worth it. And when you're able to plan a little bit, you, one, get a lot more money in rebates, but you're just going to have a better home overall. And I'd love to talk about a couple real world examples of what this looks like on perhaps completely opposite ends of the spectrum. So one, let's take a typical Denver, let's say near downtown, brick 1904 build duplex, where often it's one story, it has an attic, and then it has a crawl space underneath or a basement with low ceilings. And this was one we did. We do these often, but just in the last week or two, we worked with the homeowner to get the energy audit. We didn't do the energy audit, but we got the energy audit done. We reviewed the report together. They had an 18 ACH 50, which means 18 air changes per hour on the blower door test, ultra leaky. And just to give you an idea, new code for building tightness is 3.
Yeah.
Right. So
we're 6 times, right?
And it doesn't have to be just this home. We often see the ACH level, or the air leakage rate, we should say, from 9 to 18 or somewhere in there. Yeah. So just sealing up the home itself, it would decrease the heat pump size by maybe a ton or so of heating.
Putting a heat pump in that house at 18 air exchanges,
right.
You're talking about like 500% wasted heat compared to a current modern building.
Yeah, exactly. Gosh. So in this example, we needed upgraded attic insulation. Starting point might have been I think R11 or 12, and we do the upgrades, you get rebates, and go up to R50 or 60. Then you do the air sealing, and all of a sudden, their ductwork in their home can fit a ton or two less of heat pump size needed, and then it speaks to all the other benefits. So the other example would be, again, the complete opposite. A new build home, let's call a 2022 build home, which is a heat pump we installed and finished yesterday by the DU area. And this home has past tense and current, 2 AC furnace combo And we're actually doing new heat pumps because the lines were buried under the ground, and the refrigerant leaked out when the new build went up, which is really unfortunate.
Don't bury your lines.
Yeah,
Not in Colorado. Don't let them do that.
don't bury the refrigeration lines. But we're replacing the old systems with the heat pump, and we did the blower door test. We know that the insulation levels are stellar in this home because it's up to code 22 build, and they need a very small heat pump for this 5,000 square foot home. Actually, two very small heat pumps, one upstairs and then one downstairs in the utility room for the main floor in the basement.
Yeah.
And typically basements don't need a ton of no pun intended, heating or cooling because it's protected by the earth and the other building materials and so forth. But in this case, the building envelope was so good that a very small heat pump took care of their entire main level and the basement, which was about 3,000 square feet just on its own.
That was a really nice install. We had a lot of fun on that one.
Yeah.
Yeah.
And every home's different. Your home's going to be different than anyone else's. And it really does start with that energy audit. And then the other benefit of getting that energy audit in the Excel Energy program, I should say, is that you need it. It is required to get any of the whole home efficiency bonus rebates in the area, at least how the program's set up right now.
Yeah. Yeah, and you spanned 120 years pretty quick there, and with
That's right.
you bookended the whole span of code language, and I just wanted to fill in a gap there on the mid-century 1900s builds. These ones were just built thin. They were built foundationally on cheap gas, just burn-in, and high leak rates, zero insulation, even here in a cold climate. So we saw building envelopes basically tank from 1930 to 1940 and definitely in 1950 where they bottomed out in efficiency. So if you're in kind of a 1950s, 60s, 70s home, those are going to be ones where your insulation is very, very thin. Leak rates could be very, very high. And so just be aware of that as a homeowner. You might be in one of those, which has a lot of room to improve, just... And then what do you think about unconditioned spaces? We've been in so many homes with unconditioned spaces where you just have leaky ductwork.
So it certainly depends on the home. Some homes, especially in Denver, have half basement, half crawl space, or full crawl spaces, which is technically open to the outside. Or unconditioned space, you want to seal that off from the conditioned space generally. And if the ductwork is in the unconditioned space, it's not too bad usually when we find it when it's underneath the home, when you're in your crawl space. But if it's in the attic, it's completely open generally to the outside. And that needs more insulation, more air sealing on the ductwork itself, or duct sealing as we call it. And you just kind of go home by home and analyze it from low-hanging fruit perspective. I think there's a general decision tree to start with, because especially in Denver, every home's different. It's so many different designs, and then what's been done through it over the years. Windows, I was going to touch on windows and a couple other projects. A lot of people ask us about windows and upgrading those, and we know how expensive that can be. But that also generally is not the low-hanging fruit when it comes to air sealing. Sure, make sure the glass and the window panes, you can use some cheap weather stripping if you like. But in general, the head of the Excel Energy Auditing program, he'll tell me glass is glass, right? You can have 2 or 3 panes and gas filled, but generally windows, unless you get ultra space age expensive stuff.
Oh, quadruple pane argon filled?
Yeah, quadruple pane.
No, they're doing Krypton these days.
Krypton. all the ons. Yeah. But if generally, unless you're doing something like that, windows are windows. And we find that a lot of old windows, especially with storm windows in between, you have an air gap in between the 2 panes of glass, generally adequate and not something you want to spend tens of thousands of dollars on for the benefit that it provides. But crawl spaces, we do find often, if you have cold floors, that's an indicate where you want to seal encapsulate your crawl space, as we call it, which is not only air sealing the floor and the walls, but also put insulation on the walls at least
Yeah.
to kind of seal in the bottom layer of what's under your home. And then especially air seal your attic, what's called stack effect, where if you can seal off the top, it will stop pulling cold air from below as well. It stops the airflow going up and down.
I sealed my crawl space recently, just this past January, as part of another project, and it was a game changer.
Yeah.
I mean, going from dirt floors, just nasty crawl space, military crawl, so dirty, wearing a mask, to just nice vinyl covered floor with insulation on all the walls. And I saw two things. Number one, I didn't mind going down there as much. And I have spent a lot of time down there. And then the other thing was the droop. So my heat pump at my home, it would, no backup heat, no supplement heat. So I'd set it at 68. It would droop during the coldest nights. And that really helped basically keep my home warmer. That thermal envelope, the less cold crawl space, really boosted the energy efficiency and the comfort of my house.
Yeah.
I got to experience it firsthand.
And I think you mentioned that there was like a smell underneath the crawl space that kind of went away from the ductwork.
The installers, they just ran the condensate straight into my crawl space. So I came home that summer and there's just black mold just breeding itself wildly on down there. And that was 2 days of cleanup. And then that was before I started this company and knew anything about HVAC, but I knew what black mold was.
Yes.
And I knew that was a mistake. And so I did the research, installed the condensate pump, a proper condensate line, and ran it to the garden. You know, so watered some plants, made some mud there.
And that speaks to the health and safety of the building science part of this. And actually in the energy auditor training, they touch on safety before air sealing and energy efficiency. Like before sealing an attic, for instance, we're taught to look for sometimes the partition wall between the garage and the living space, because a lot of homeowners keep paint and other chemicals, acetone, whatever you have laying around, and those are off-gassing, leaking into your home. So we actually seal off things like the garage. But in a case like yours and many others, we want to seal off the attic and the crawl space and unconditioned space because there are bugs, there are rodents, there's mold, there are all kinds of stuff that's really unhealthy that's leaking in and out of your home all the time. And you usually can't stop all of it, but you can prevent a lot of it you can slow it down quite a bit. But to bring it back to heat pumps, we tackle many of these items in relation to the heat pump just working more efficiently, quieter, fitting the ductwork, and it's amazing to me almost daily as we dive further into heat pump design how closely these are all tied together in terms of proper design.
Oh, absolutely. Yeah, and just to kind of bring it back home and double down on what you just said is that the building envelope, its efficiency, whether good or bad, is the driver for equipment size.
Yes.
Yeah, and that sums it all up.
And when we don't have that energy audit or don't have that blower door data or the insulation levels, we honestly feel like we're kind of flying blind.
We're just guessing.
Hey,
it's about a 3-ton. It's about a 5-ton.
Yeah. And that's a whole other podcast, but the old rules of thumb we find do not apply to heat pumps.
Yeah. What's on the truck? That'll fit.
Yeah, that's right. Great.
Yeah. And thanks again. Stay tuned for the next one.
Thank you.